Good morning, students. In this video, I will explain you the numerical part of chapter force and pressure. I hope all of you have done these numerical in your physics interleave copy. So today we are going to understand the numerical. First question is, find the moment of force of 20 Newton about an axis of rotation at a distance of 0.5 meter from the force. Now in this question, moment of force is given, and we have already studied that moment of force is equal to force into perpendicular distance. So it's easy to solve. You have already solved the solution in your copy. I have given you in the PDF form. Let's see how to solve this question. In the question it is given, you have to first write whatever is given in the numerical. So in given part is force, which is 20 Newton, and perpendicular distance is given as 0.5 meters. Now moment of force will force into perpendicular distance. So force is given as 20 and perpendicular distance is given as 0.5 meters. So it will be 20 into 5, which is 100, but we have to put one decimal after one digit from right hand side, so it will be 10 Newton meter, which is the unit of moment of force. Next question is given as question number 3. They are saying a spanner of length 10 centimeter is used to open a nut by applying a minimum force 5.0 Newton. Calculate the moment of force required. Again the question is same. Given part, perpendicular distance is given as perpendicular distance is given as 10 centimeter and force is given as 5 Newton. So you have to find the moment of force. So moment of force is force into perpendicular distance, which is 5 into 1 by 10. Why we are writing 1 by 10? Because it is given in centimeters. So we will convert this centimeter in meter, and for converting this centimeter in meter, we have to divide it by 100, because 1 meter is equals to 100 centimeter. So 10 centimeter will be 10 by 100, which is 1 by 10 meters. So it will be 0.5 Newton meter, which is the unit of moment of force. I hope it is easy. The next question is question number 5. They are saying a normal force is 200 acts on the area of 0.02 meter square. Find the pressure in Pascal. Okay. So it is given force and area is given as meter square. How we can know that this is area? Because this unit is meter square, which is for area, and we have already studied the formula for pressure. Pressure is force per unit area. We have already studied in the explanation part of pressure portion. So it is force per unit area, so which is given as 200 upon 0.02 meter square. So just cancel it. We will get 1000 Newton per meter square, and this Newton per meter square is also called as Pascal. So we can count the 0, 1, 2, 3 and 4. 4 zeros are given here, so we will write 10 to the power 4 Pascal. This is not very difficult numerical. It's very easy to solve. The only thing you have to understand the theory part very properly. The next question is, find the area of a body which experiences a pressure of 50,000 Pascal by a thrust of 10 Newton. Student, as we have already studied, that thrust is nothing but force. So in the question it is given as pressure, which is given as 50,000 Pascal, and force or thrust is given as 100 Newton. So pressure will be applied as force per unit area. So pressure is 50,000, force given as 100, and we have to find the area. So from here we can easily find the area by cross multiplication, and which will be 100 upon 50,000. So it will be 10 upon 5,000, and we'll just do it in the powers of 10. You can see by cancelling this we will get 2. So 2 into 10 to the power minus 3 meter square, because we have to find area and unit of area is meter square. So it is 2 into 10 to the power 3 minus 3 meter square. Why we are writing minus 3 here? Because this 10 to the power 3 is given in denominator, and when this will go to the numerator it will be minus 3. The power will become minus 3 from plus 3, because it has been shifted from denominator to numerator. The next question is saying how much thrust will be required to exert a pressure of 20,000 Pascal on the area of 1 centimeter square. How much thrust? It means we have to find force. So pressure is given as 20,000 Pascal, area is given as 1 centimeter square, which is also called as 10 to the power minus 4 meter square. Why we are writing 10 to the power 4 meter square? Because 1 centimeter is equals to 1 meter is equals to 100 centimeter. 1 meter is equals to 100 centimeter. So 1 meter square will be 10 to the power minus 4 centimeter square. So 1 centimeter square is equal to 10 to the power minus 4 meter square. Now pressure is equals to force upon area. So force is given. We have to just find the value of force. So we'll just find by cross multiplication pressure into area. So this is 20,000 upon 1 into 1 upon 10,000, which is 2 Newton, and unit of force is Newton. So the answer is 2 Newton. We have to find force in this question. The next question is saying, next question you can see question number 10. The base of the container measures this much by this much. It is placed on the tabletop of the weight of the container 60 Newton. What is the pressure exerted by the container on the tabletop? What is the pressure? It means we have to find pressure in this question. So given area of the base is 50 into 20, because to find area it is length into breadth. So convert the centimeter in meters. So we will get 300 upon 10,000 meters square. Weight or force is same. Force and thrust is same. So it is 60 Newton. Pressure is force per unit area. It will be 60 upon 300 into 10,000, which is the value of area. Area is given as 3,000 upon 300 upon 10,000. So let's solve it. 60 into 10,000 upon 300. We will cancel the 0 and we'll get the answer as 2,000 Pascal. Next question is question number 13, the last one. You can see the 3 slabs are placed here in the different position. First has been horizontal, vertical, and then again in a horizontal way but in a different manner. Now you can see these are the brick slab. Weight of the bricks is given as weight, that is force is given as 2 kgf, and dimensions are given as 20 centimeter into 10 into 5, placed on 3 different positions. So first we will find the first position. we have to find how much pressure is exerted for first brick. So let's solve. Weight or thrust of force is given as 2 kgf. Area we will find, which is 20 into 10, 200. Then we will solve it, put the values, we'll get 0.01 kgf upon centimeter square. You can see the values are given in CGS form, kgf and centimeter. We need to convert it. If one of the values is given in SI form, then we have to convert it. The next position, slab is 5 into 10, so it will be, from here we can find the area, which is 50, and then pressure, we'll put the value, we'll get 0.04 kgf per centimeter square. Then again, for the third position, it is 20 into 5. Pressure is force per unit area, which is 2. Again, area is 100, so it is 0.02 kgf per centimeter square. So this is the way we are going to solve the numerical. You can solve other numerical also in your rough, and you can ask your doubt if you have. Next time we will start the new chapter, which is energy. And the student, just complete your work in your copy till the numerical part, because I will be checking your copies very soon. Thank you.